There are just a few ways to make covalent bonds that are important in organic chemistry. Because we're talking about carbon as a central element in these compounds, let's talk about making bonds to carbon. And if carbon has 4 things attached, it already has a filled valence shell. So we don't expect a lot of chemistry there. But if carbon only has 3 things attached, it could have an empty orbital and need a pair of electrons. So one of the ways that's common and important in organic chemistry is for some ion or molecule to donate a pair of electrons. To form a bond, carbon gains a filled outer shell, which is the driving force for the reaction. Carbon now has an octet of electrons around it. And if that species that donates a pair of electrons was neutral, it will have a positive charge. A second possibility is that that species that donates a pair of electrons is negatively charged. This is also common, in which case what we make is neutral. There's our pair of electrons making a bond. I have used the symbol Nu there, which is something that we call a nucleophile. Anything that shares a pair of electrons with carbon falls in this category. You know, if something shares a pair of electrons with a proton, we call it a base. When something shares a pair of electrons with a carbon, we call it a nucleophile. And we abbreviate this Nu, and it could be one of many things, but common nucleophiles are heteroatoms. So something that has oxygen is very common. Something that has nitrogen is very common. A halogen is very common. All nucleophiles. They may be negatively charged or they may be neutral. Another possibility would be carbon atom having a pair of electrons sharing with something that needs a pair of electrons. We typically will picture that as something that is positively charged. And now the arrow pushing goes the other way. From carbon to the electrophile, carbon typically would be negatively charged, and we'd have a neutral product. Now if E+ were a proton, we'd call it an acid, but if it's not, we'll call it an electrophile, something that likes electrons. So we have nucleophiles that like the nucleus and electrophiles that like electrons, and their behavior is exactly the opposite. Common electrophiles would be carbon with a positive charge, halogen with a positive charge, or something similar to it, are examples. And we could picture, and this happens for carbon commonly, even a neutral carbon-carbon bond reacting with an electrophile. So a pair of the electrons in the double bond, the pi electrons, from the pi bond to the electrophile, that pair of bonds is used to make a covalent bond with carbon. And there would be a positive charge on carbon, the carbon that lost the pi electrons. And of course, carbon would need to have other things attached, so you better put them in for clarity. And so here's another common way for bond making in organic chemistry, electrophile reacting with the pi bond. So organic chemistry, in essence, is quite simple. It's the breaking and making of covalent bonds. In our course, we'll be talking about charge-driven reactions, almost exclusively. And therefore, we'll be talking about heterolytic bond cleavage, heterolytic bond making, and using arrow pushing to track what happens with electrons. It's really quite easy to understand the basics of this bond making and bond breaking. The reaction of doubly bonded atoms isn't limited to carbon-carbon. Take a look. Carbon-oxygen is very common, and it's easy to predict because these atoms have different electronegativities, where a positively charged or a negatively charged species will react with this carbonyl bond. It's very important in synthetic chemistry, and it's very, very important in biology, so we're going to talk a lot about it. It's partially negative charged, and carbon is partially positive charged. As little as we've talked about bond making and bond breaking just in this lecture, it would be easy for you to predict that a nucleophile, let me make it negatively charged, but it doesn't have to be, would tend to react at this carbon, and that an electrophile would tend to react at oxygen. But in reality, the positively charged species that we see are acids. I'm going to write H+, and we can easily see that a pair of electrons could react where there's a partial positive charge, negatively charged electrons reacting by being drawn to positive charge. And this pair of electrons, which has excess electron density on oxygen, forming a bond with that hydrogen. And so, just on the principles that we've talked about already, that a carbonyl group will add a nucleophile to carbon and a hydrogen to oxygen. And because we're starting with a positive charge here and a negative charge here, the overall thing is neutral. And this is another very common kind of bond making, bond breaking process that we see in organic chemistry. The carbonyl group adding a nucleophile at carbon and a proton on oxygen. My point is that, not that this is important in chemistry and you need to memorize it, but my point is this is important in chemistry and we can easily understand it with very simple principles that we've talked about. You'll see that as we talk about various chemical reactions, to see same kinds of principles about bond making and bond breaking let us understand all kinds of important chemistry rather easily.